Good morning, students. This is Mrs. Sadi Joseph, your physics teacher. Welcome back to the online teaching for the session 2020-21. Let us proceed with the same chapter, that is chapter 10, gravitation. In the previous video, we had seen what is acceleration due to gravity, why there is a variation in the value of acceleration due to gravity, how to calculate the value of acceleration due to gravity. So, what is acceleration due to gravity? The earth attracts every object towards its center with a force. This is called acceleration due to gravity and is denoted by small g. Why there is a variation in the value of acceleration due to gravity? It is because the radius of the earth is not same in all the places. At the poles it is minimum and at the equator it is maximum. So the value of G is maximum at the poles and minimum at the equator. Also we had discussed how to calculate the value of acceleration due to gravity. What is the value of acceleration due to gravity? That is equal to 9.8 meter per second square. But it is not constant. It varies from place to place. In this video, we will see what are the equations of motion for freely falling bodies and what are the differences between mass and weight. Since the freely falling bodies fall with uniformly accelerated motion, the three equations of motion under uniform acceleration can be applied to the motion of freely falling bodies. Are you remembering what are the equations of motion? Yes, first equation is V is equal to U plus AT. Second equation is S is equal to UT plus half AT square. And third equation is V square is equal to U square plus 2AS. For freely falling bodies, the acceleration due to gravity is G. So we replace the acceleration A of the equations by G, and since the vertical distance of the freely falling bodies is known as the height h, we replace the distance s in our equations by the height h. This gives the following modified equations for the motion of freely falling bodies. So when we replace A by G and S by H, our equations changes into V is equal to U plus GT, H is equal to UT plus half GT square, and V square is equal to U square plus 2GH, where U is the initial velocity, V is the final velocity, H height, G acceleration due to gravity, and T is the time taken. You should remember these equations for solving the numerical problems. We should remember the following important points for the motion of freely falling bodies. First point, when a body is falling vertically downwards, its velocity is increasing. So the acceleration due to gravity g is taken as positive. That is, acceleration due to gravity is equal to plus 9.8 meter per second square for a freely falling body. Second point, when a body is thrown vertically upwards, its velocity is decreasing. So the acceleration due to gravity g is taken as negative. That is, acceleration due to gravity is equal to minus 9.8 meter per second square for a body thrown upwards. Third point, when a body is dropped freely from a height, its initial velocity u is 0. Fourth point, when a body is thrown vertically upwards, its final velocity v becomes 0. And the last point is, the time taken by a body to rise to the highest point is equal to the time it takes to fall from the same height. So when you solve the numerical problems related to this, you have to remember all these points. Let us move to our next topic, that is mass. What is mass? Mass of an object. The mass of a body is the quantity of matter contained in it. I repeat, the mass of a body is the quantity of matter contained in it. It is a scalar quantity because it has only magnitude, no direction. The mass of a body is commonly measured by an equal arm balance, or we can say a common beam balance. And what is the unit of mass? The SI unit of mass is kilogram, which is written in short as kg. A body contains the same quantity of matter wherever it be, whether on Earth, Moon, or even in outer space. So the mass of an object is the same everywhere, or it is constant. For example, if the mass of an object is 5 kilograms on the Earth, then it will have the same mass of 5 kilograms even when it is taken to any other planet or moon or in outer space. So we can say the mass of a body is constant and does not change from place to place. Mass of the body is usually denoted by the small letter m. The mass of a body cannot be 0. Our next topic is weight. You know that the earth attracts every object with a certain force, and this force depends on the mass of the object and the acceleration due to gravity. So the weight of a body is the force with which it is attracted towards the center of the earth. What is the definition of weight? The weight of a body is the force with which it is attracted towards the center of the earth. In other words, the force of earth gravity acting on a body is known as its weight. We know that force is equal to mass into acceleration. That is, F is equal to m into a. The acceleration produced by the force of attraction of the earth is known as acceleration due to gravity and written as small g. Thus, the downward force acting on the body of mass m is given by F is equal to m into g, where g is the acceleration due to gravity. The force of attraction of the earth on an object is known as the weight of the object from the definition, and it is denoted by capital W. By substituting the same in the equation, we have W is equal to m into g, where m is equal to mass of the body and g is equal to acceleration due to gravity. Weight is measured in the same units as force. What is the SI unit of force? Yes, it is Newton. So the SI unit of weight is also Newton, which is denoted by the letter capital N. The weight is a force acting vertically downwards. It has both magnitude and direction. So weight is a vector quantity. The weight of a body is given by W is equal to m into g, and since the value of g changes from place to place, therefore the weight of a body also changes from place to place. The previous module we had seen that the value of small g varies from place to place. So the weight of a body is not constant. In the interplanetary space where g is equal to 0, the weight of a body becomes 0. Because of this, we feel weightlessness in the space. Thus, the weight of a body can be 0. Mass of a body cannot be 0, but weight of a body can be equal to 0. Weight of an object on the moon. Just as the weight of an object on the earth is the force with which the earth attracts the object, in the same way, the weight of an object on the moon is the force with which the moon attracts the object. So what is the weight of an object on the moon? It is the force with which the moon attracts the object. The gravitational force of the moon is about 1/6 that of the earth. Therefore, the weight of an object on the moon will be about 1/6 of what it is on the earth. For example, suppose the weight of a body to be 6 Newton on earth, then what will be the weight of the same object on the moon? 1/6 of 6 Newton, that is equal to 1 Newton. The weight of an object on the moon is less than that on the earth because the mass and radius of moon are less that of earth, due to which it exerts a lesser force of gravity. This is the end of today's module. We will solve the numericals related to these topics in the next module. Read the portion nicely, understand it. Your midterm exams will be coming in the next month. Prepare for the exam, complete the notes, concentrate in your studies. Thank you. Bye bye and take care.